Just trying to, is this drawing according to like where the focus coordination is?
Is the motor cortex bigger than the sensory?
No, and I knew that question was coming. They're essentially the same amount of cortical area.
Okay.
From So actually, motor cortex, the information comes out from the brain. Sensory cortex, your finger sends information to it. So there's a dual directionality to this. And the only reason I'm going back over this is that one class got all this information, the other class, this is pretty much where we left off, and I wanted to make sure that we get this clear. The way I remember the motor cortex and the sensory in terms of which one is located, very simple. M comes before S in the, here's your eyeballs, M from front to back comes before S. So does the motor come before the sensory. Now, we want to make sure we get the, I guess it's on.
Yeah.
I'm doing its thing. I want to make sure that we understand these two drawings. Again, this is a repeat for half of you. The motor cortex is in red, and it literally goes from ear to ear, or it's actually in front of the ear, okay, but it goes from one side of the head completely across to the other side. Now, if it's red, then that means that this is part of the cortex. It's part of the outer layer of the brain. And what that means is that the amount of fine motor movement involved in coordinating muscle movement in particular parts of your body, if it is something like your mouth, your facial muscles, your lips, your tongue, all of these require a great amount of fine motor. And so more of the surface of this motor cortex is dedicated to those parts than to other parts that don't, first of all, require a great deal of fine coordination, like your forearm. Your arm gets very little. Your fingers and hands get a good amount of cortical area. And if this drawing looks funky, it is just totally representing what that real estate is divided up on the motor cortex. And then it's the same thing on the sensory cortex, which is right behind it, right next to it. Now, the motor cortex is in the frontal lobe. The sensory cortex is in the parietal lobe. And again, we have the exact same concept of those things in terms of your senses that are highly, highly sensitive. Those are the ones that get more surface area. And those that are not, like your neck, probably not as sensitive as your fingertips. And I'm also looking at the axons. I skipped ahead to looking at the axons. So the axons send sensory information to the cortex. Okay. I've never really paid attention to that before. The direction of the axon information flow, on the motor cortex, the information goes down through the axons from the cortex and goes and gets coordinated with other parts of the brain. In terms of the sensory cortex, the information comes up through those axons to the sensory cortex, and I guess that makes really very good sense. I just never paid attention to that much detail. Does this make sense, these strips? Okay. Yes? Anything else here? Okay. Make sure you understand also everything we're talking about in your brain. Not every single thing, but most things. The left hemisphere controls the right side of the body and vice versa. I will tell you, so you can prepare ahead of time, a little bit about the free response on the exam. Yes, even though it's take home, it doesn't mean you get to use any resources. The free response is just one question, and actually there's two on the test, but you're to ignore the first one. The one that's bigger and involves specific brain parts are the ones that you have to. So and so has been in an accident, and obviously it's an accident that has impacted his head, and what's going to happen to, and I'm going to list certain brain parts, the functionality, will he recover, how will he recover, so you really need to know what each one of these brain structures does, and also that crossover between the left to the right. So if he's hit in the left side of the head, what's that going to do to him?
Right side.
But it also depends, and in a minute we're going to talk about language. It also depends on thinking about language is only on the left side for the majority of people. Okay, now we're looking at this slide. I did some extra, kind of close scrutiny of this slide. Sensory functions of the cortex. Again, we're not looking at lobes here. We're not looking at the whole occipital lobe or the whole temporal lobe. We're looking at very specific things that the cerebral cortex does in terms of sensory information. Obviously, the sensory strip, which is the one in the previous slide, has to do with touch. So information coming from those parts of the body to the cortex. Now, in the occipital lobe, so here's other information about sensory areas of the cerebral cortex. In the occipital lobe, oh, Cameron, I have papers for you over here too.
Okay.
Let me send them your way. Bless you.
Thank you.
Okay, in the visual cortex, and this is in the occipital lobe, this is where the information coming into the occipital lobe from your eyes begins to be processed. So it's just being mentioned because what parts of the cerebral cortex deal with sensory information? Well, the visual cortex is one of them, in addition to the sensory cortex. Another is the auditory cortex. It's right above your ears, okay? So in the temporal lobe has the auditory cortex, where sensory information comes in and it begins to be processed there.
Thank you.
Just making sure that I'm not leaving anything out. And you have that on obviously both sides of your head because you have two ears. But the information, again, that comes into your left ear gets processed on the right side, on the right temporal lobe, the auditory cortex. So these are small areas. The whole lobe is bigger than that. Okay, let's see. Now, we need to talk about, actually there were only three. The sensory cortex, the visual cortex, the auditory cortex, in terms of cerebral cortex areas dealing with sensation. What the heck are association areas? These are also areas located all through the cerebral cortex, the whole covering of your brain. And I think it really is important to see, before we talk about what it does, to see that that evolutionarily more complex animals have differing amounts of, I think this picture here really helps to understand how much of a rat's brain is dedicated to the motor, like movement. Is that?
Hey. I'd like to play my last 10 minutes of being late on Mirza. She was the worst person.
Zach, did you get the lanyard?
Yeah, she said it's at the lower school gate, so I parked at the lower school and I
Yeah.
walked around for like 10 minutes trying to find the gate that had a
Oh
lanyard
my
on it.
god.
And then I was like,
That
okay,
gate.
that's
The
not it.
gate. The
She
gate.
goes, no, like the middle school one. I was like, okay, so I parked in the middle school parking lot and I looked at the gates there and there's nothing there. I was like, what are you talking about?
No, they're like the only one.
I'm
only-
glad you're inside, but
Door key.
where's my lanyard? I guess is my.
It's still on the it's still on the thing.
Oh my Zach.
She never said to get it.
Okay, so which gate is it?
The high school gate.
The one between
The
leadership
one that
lane.
isn't the baseball field.
Huh?
The gate that isn't the baseball field.
It's around the
Never
post
Yeah,
there.
there's only 2 gates.
Yeah, but I thought you meant like the walking.
Well, there's more than one gate for his defense.
Party.
I thought you meant like the
Well, I mean, it's car gates. There's
Yeah.
only 2 car gates, right?
Yes.
Am I missing one?
No, there's only 2.
4 ones. Yeah, this
Lame.
Okay,
Could you
so I need to
imagine
do a
Zach
little field
watching
trip out there to
Mr.
pick it up on my way out.
Yeah, I'll grab one.
Okay, hope no stranger comes along and gets Yang's heavy computer.
What are they
out
gonna
of the
do
building.
to the school when we're on holiday? Like, we're
It's
not-
Yom Kippur.
Yeah, it's Yom Kippur. Why would
They would never do that.
Why would what?
Why would they be here though? Why would some stranger be here in the first place? Like, do you think they care what day it is? Yeah, why, wouldn't they want to be here when kids are here? Wouldn't they want to be here when kids are here?
Well, they probably don't know that we're not even here anyways.
Someone who wants to steal.
Matt, are you honestly video?
Yes.
Thanks, Matt.
Most people from school, they want to do.
That's no.
Okay, Abby, don't be logical.
My
Stop.
bad.
Stop being logical.
My bad.
Yeah,
Sorry
really.
about it.
What were you thinking?
Logically.
Well, yeah, apparently. Okay, look here. Look at this little rat brain. I know, it's not pretty, is it? And it's really just, okay, I know what Stella just said. No, maybe you didn't. I did.
No, she said it looks like a finger, so I went like that.
Like a thumb. But okay. Let's go on.
Okay, can I put your Alright, look. Look at the motor area.
That's it.
But look at a rat. He has to get so much of his information from his senses. His whiskers are hugely important, believe it or not, in that whole process. So much of his brain is dedicated to sensory information. And whoa, can I even see? There must be a wee bit of association area, which is, again, not motor, not sensory. It must be association then. But I don't see.
It's right in between the red and the.
Oh, okay. I can't honestly see it that far. Now the cat's brain is a good deal more complex. So the motor cortex is about as big, and there's a great deal of sensory, but we begin to get association areas kind of scattered throughout. And then if you would compare a chimp with a human, they are very similar, honestly, but we get a great deal more of the frontal lobe. That's probably one of the most noticeable differences. And again, they have a great deal of association areas, but the humans have even more. And that's just a really good visual. So what are the association areas? Can anybody explain it?
You associate things?
Hmm?
You associate things?
Yeah. You know, this
There's
way of...
spatial, or not spatial, like the reading, or I don't know, was it reading or something? Or was that
No. Stella?
Association areas of the cerebral cortex that are not involved in primary motor or sensory functions. Rather, they are involved in higher mental functions such as learning, remembering, thinking, and speaking.
They're all over the brain, and they don't have a dedicated well, they do have a function, an extremely important one, but they don't have a specific dedicated function. They're all of these things that make humans human. They are areas that integrate and coordinate information and are areas that actually, they act on information processed by the sensory, that integrate information
But you said integrate and what?
Coordinate.
and coordinate information. Input, okay, I won't call it information, but it is nonetheless. They act on sensory input, info. Now, humans have more than any other animal. I can't say that. They don't have a whale brain or a dolphin brain here. I would like to see that, actually. But of the primates that we are talking about, have the most. This is in the cortex, okay? It's not located deep in the brain. Just note that. Everything involved in judgment, thinking, reasoning, executive function, all of these things are part of the association area.
Would you think, like, because a whale is so big that they have a much larger brain, or do you think it's more the same size, or even smaller than ours?
Makes me want to look it up. I don't know.
Wouldn't it be like ratio?
It would have to be, obviously, it's not going to be 3 pounds.
Yeah. But like our brain to our body is bigger than a whale's brain to their body.
I'm going to make that guess.
Well, like the gorilla, though. The gorilla is a much bigger animal than we are, but our brain's more.
Their brain in their head may be bigger and heavier, but they surely do not have the frontal lobe development. So there are specific executive functioning, reasoning, thinking, planning. All of these things are the things that are the domain of the association areas. And they are, again, because they're all through the cerebral cortex, they're located in all 4 of the lobes. And the reason humans can speak is because there is so much coordinated information passage through the association areas. Okay. Now,
Sperm whales have the largest brain, which is about 18 pounds.
what does
Sperm whales,
an 18-pound brain?
Yes.
But yeah, again, how is that ratio to a human?
reading that.
That's not that. Ours is 3 pounds.
and
That's
brain
6 times
is-
bigger.
Our brain is
Yeah, I looked it up.
I want to see a real brain.
You put on weight in your
It's
brain.
really cool. What?
Put on weight in your brain.
Miss Turner, this is
Gains.
a dolphin brain next to a human.
Great. This one, let's see.
Yeah, I looked that up too. It just sounds
Whoa. Whoa. It's got a ginormous, what appears to be cerebellum. But
It's well because their head is weirdly shaped.
it's got more convolutions. Take a look at that. Than the human brain.
Oh!
Wrinkles.
Yeah, so there's no exact like ratio because like no matter how like the mammalian brain increases in size, they're not all parts are going to increase at the same rate. So there's no like ratio to it because it can't just if it's a ratio, everything in that brain has to grow like the same way as one other brain. A human brain compared to like a dolphin brain, every part of it, in order for it to be the exact ratio, would have to grow at the same rate.
It's like an app.
Does that make sense?
I think so.
Okay. So like, there's no exact like ratio.
Because everything would have its own ratio.
Exactly.
Thank you. Okay, we need to pass on. Let's see. See, I'm always afraid that I'm going to miss something important here. All right, we already talked about the fact that the parietal lobe is involved in your ability to do math, spatial relations. Looks like Kira, I think.
No, she doesn't drive.
Oh,
Yeah,
okay.
she does.
Seriously?
Yeah, she has her license.
They look nothing like Kira.
Yeah, that's also not what she drives.
Yeah.
Okay.
I didn't know she drove.
Maybe they got
You
it.
got
Kind.
So some of the things that, for example,
Again.
in the temporal lobe, just so you'll know, in the temporal lobe, yeah, we think about hearing and auditory processing, but that disorder, a specific thing we talked about that Kira had the name for, prosonoscopia. That's not correct. Where you can't remember faces, where Stella told us about the doctor. Actual facial recognizing specific faces, that's actually the domain of the temporal lobe, believe it or not. Which you wouldn't think that there would be anything in the temporal lobe having to do with facial recognition. Okay. These are just one more thing, just other things that the association areas deal with. Memory and language, attention and consciousness. If a person is able to meditate, I'm not going to put spirituality in that, that just sounds like it's a little, but if a person is able to meditate, which means putting your brain into a different state in terms of the brain waves, that's all part of association areas. Okay, now we need to look at some very specific things, one of which is speaking, reading, decoding words, and it seems so easy for us to open our mouth and words to come out that make sense. It seems so easy for you to take a book and to take those printed squigglies and decode them, and then to be able to read that book aloud and to make those words make sense. It's a hugely complex task. So we need to take a look at reading and language and specific brain parts. Okay. It involves 5 steps, actually, that are quite specific, and it kind of goes from the back of the brain to the front in terms of processing. All right, so you know that when you see something, see words, it comes in. Now this is not correct because I don't want to confuse you yet with what the eye does with with the left and right visual
like,
field.
And then that.
It's
and then
Have like 2 paths.
but I don't want to go there yet. All right. So first of all, first step is in the occipital lobe, visual cortex, so that the information for the written word, okay, we're reading now, comes in, words come in and visually are processed here. okay, in the visual cortex. And then they move forward into the angular gyrus, which is the pink thing in the picture. It is not in the occipital lobe. I think it's in the parietal lobe. So somewhere here. I don't know whether it is. Honestly, don't know whether you have that on. I believe it's only on the left hemisphere. All of this is on the left hemisphere. So here we have the angular gyrus, step 2. And if I'm wrong about it being on both sides, I'll let you know. So what happens is it takes what you see visually and decodes those letters into something meaningful. So it, angular gyrus decodes written letters and words. And then we move forward to an area that is only in the left hemisphere. So it leads me to believe Broca and Wernicke, those two areas are only in the left hemisphere, so I'm assuming the angular gyrus is too. So here we have Broca's area, none of these drawn, well. So step 3, I didn't mean to say Broca's area, I meant to say Wernicke's area. This allows us to understand, not just decode it into words, but to understand. If someone is now reading to you, now this is only for auditory, okay? So let's say you're taking in information here, you're reading it, you're decoding it, then you're going to read it aloud. Well, one of the steps in that is that when you're reading it aloud, you're going to make meaning of it for yourself, and it also the Wernicke's area. Your Wernicke's area right now is allowing you to understand my spoken words. It's not just a bunch of sound waves coming at you. It has a meaning in a context. So the Wernicke's area allows understanding.
Does it have anything to do with when you're learning new languages? Does that area work more?
That's a good question. Oh, I'm sure it's definitely used, but I don't think that anybody has a lesser or greater ability to learn language based on the fact that your Wernicke's area works better than somebody else's, or that your Wernicke's area probably worked more competently when you were 2 as opposed to when you're 42.
Wait, isn't it that it's more flexible between the ages of
Birth
3
and
to 8? Yeah,
birth to 12, or puberty, whenever that happens. You lose the ability for learning foreign languages without an accent. So your first language was?
Portuguese, then I learned Spanish when I moved here, and then I learned English in school.
So how old were you
7.
when you began learning English?
7.
11?
7.
Oh, 7. Did you know that she's Portuguese?
Brazilian.
English is not her first language? You never know it, right?
It's my 3rd.
It's your 3rd language, which makes your brain richer, thicker, denser, and more, integrated than the rest of us who don't have English as a first, who only have English as a first language.
You wanna do mock trial?
There, yeah, does that
Serious
make you a good
question.
lawyer? That's the question. Allows understanding of spoken word. Okay, then it moves forward to, this is actually in the frontal lobe, Broca's area. So that's 1, 2, 3, 4. Allows you to actually speak. If you have damage, and this is only on the left side of your brain, if you have damage to your Broca's, like people who have strokes, and this is so often, this is what happens, when people can no longer speak after having a stroke, it's often because their Broca's area was damaged. Quite literally, can no longer form the words.
When you have like alcohol and your speech like gets affected, would that get affected?
I can't tell you that I know what
Do like a
alcohol.
PET scan? Well, do a PET scan on a drunk person and have them speak.
Let's do it.
Who wants to get drunk?
Let's get drunk right now. Wednesday morning.
Yom Kippur.
Yom Kippur, right.
Yeah,
I would say that your ability to speak is still intact. Now, I'm going to guess that that's a good question, because it's slurred, really badly slurred. So what's causing that slurring? I don't know. Too many I don't knows. Spoken language. Your ability to speak is due to your Broca's area. And it is in the, okay, it's actually in the,
No, I put frontal lobe.
it is frontal lobe. It's in the frontal lobe, and it also is right next to, I mean, it's very far forward, the Broca's area is very far forward in your head, and then it sends that information to the motor cortex, so that, I would say, the answer to that is that your motor cortex is more involved in being impaired in your speaking when you're drunk.
Okay.
So what specifically, I don't know. Spoken language, and the fifth thing is the motor cortex right here in the motor cortex.
Is it behind the Broca's area? Where's that picture come from?
Is it?
Like behind?
No, it's not.
It's just on it?
No, I'm sorry. You're never gonna get me to draw anything accurately. It's attached right next to it. And it is in front. It's not in back.
Which one's in front? The Broca's area. It's in front.
Yes.
The motor cortex actually allows the muscle movements that create the words. Okay, so it goes again from the back to the front, to the front, to the front. Part of what I was actually talking about is, especially with anything with the visual cortex and the angular gyrus, those are reading tasks. And then when you start taking those written words and you want to speak them or listen to someone who's speaking, then that's when we start needing our Wernicke's area, Broca's, and the motor cortex. pretty complicated process for this thing we take for granted. Just to recall, maybe Pam, did you not get the practice test, and Zach?
No, I didn't get it.
Okay.
I have my psych sim.
Okay.
I put mine.
Okay, so take what you need there and do the answer key. Just thought it would be better to give it out sooner rather than later. Okay,
Alright, oh wait, question.
yeah,
Okay, so there's the Broca's area, and then those little things. Yeah, I think I'm just a little sick. I'm good. They're together?
the Broca's area and then the motor cortex. The Broca's in the brain is actually in front, slightly in front of, so, and they are right